All right. Today we are talking about simplifying algebraic expressions. And this is obviously not the 7th of 2018. I'm just going to mark that out completely. Simplifying expressions. To me, guys, this is my favorite thing to do in algebra. I don't know why. To me, it's kind of like working a puzzle. I like it a lot. I am going to warn you, just like everything that we've done in algebra, this is your first time ever seeing this. So on question number 1, if it's not perfectly crystal clear, that's okay. Question number 2, if it's not making more sense, let's ask some questions, okay? All right, so when we're simplifying algebraic expressions, first of all, does it say to evaluate and work it out?
No.
No. We are not working anything out. We are just making the problem simpler. Like when you simplify a fraction, we take those big numbers and make them simpler. They're smaller. They're easier to look at. That's what we're going to do here. We're going to take this long problem and we're going to make it a little shorter. We're going to make it a little bit smaller and simpler to read. When we're simplifying expressions, we're going to put a little star right here. What we're really doing is combining like terms. And I'm going to underline like terms right there. All right, like terms is one of the vocabulary words that that we did on Monday. Now on Monday we did a bunch of vocabulary. These were 2 that I said, hey, we're going to talk about that more later. Today's later. All right, does anyone remember, or can you look back to Monday and tell me what are like terms? What did we say that was? What's that definition from Monday? Macy? Terms that contain the exact same variable and the exact same power. So we need to know what a term is, just to repeat. A term is also on that sheet. A term is a number and letter, or number and variables, it could be plural, that are separated by operation symbols. So like here, 2x is a term, 3 is a term, and 5x is a term. Each piece is a term. Here, 13a, 4b, and b. There are 3 terms. Here, 8x to the second, 7xy, 5x to the second. There are 3 terms. You'll see how we're just counting those up? All right. So on number 1, I'm looking for the terms that are the same. Which ones have the same variable? Tucker? 2x and 5x. You all okay with that? That's pretty easy. Okay, the next part that I'm going to ask you to do might look a little weird. When I read this, it says 2x. Would I read anything else to go with 2x? Then it says minus 3. So what am I doing with that 3? I'm subtracting. And then I would say plus 5x. So 2x and 5x match, but the way I'm going to ask you to say that is I want you to say 2x matches with plus 5x. Because what am I actually doing with that 5x? I'm adding it. Okay? The minus sign goes with the 3. Are there any questions on how I circled that or why I circled that like I did? Okay. All right. So now the stuff that matches we're going to combine. So I'm going to start with the 2x that was at the front. It does have a match. So I'm going to take 2x and I'm going to add 5x to it. I can do that because they're the same. It's kind of like taking 2 apples and adding 5 apples, and that would give me 7 apples. But here I'm going to take 2 x's and I'm going to add 5 x's, and that's going to give me 7x, or 7 x's. Does that make sense the way I just did that? Okay. All right, have I done anything with the minus 3? So I'm just going to write that down next to my 7x. And now that's the new problem. So instead of having 3 terms, I only have 2. Did I make it simpler? Did I make it shorter?
No.
Yeah, that's our goal. Am I actually working it out?
No, subtract it's 4x.
Nope, we cannot subtract it because 3 doesn't have an x. So now we've just got to leave it there. Okay? All right, so let's look at number 2. Number 2. So I'm going to start off, it says 13a. Does 13a have anything that matches it? No. So I'm just going to go ahead and write that down. Are y'all okay with that? 13a doesn't have anything that matches it, so I just brought it right down. All right. The plus 4b, does it have anything that's going to match it?
B.
Not just b, but minus b. So I'm going to have my plus 4b, and then I'm going to have my minus b. Remember, a plus sign and a positive sign look the same, right? So I'm going to think of that. I know it says plus 4b, but I'm just going to think that's positive 4. Okay? Because eventually you'll learn to do negative numbers, and eventually that minus sign, you'll also say like negative 4b. We're not going to worry about that right now. This is just positive 4b minus b. If I have positive 4 apples, and I take away an apple, how many do I have? 3 apples. So if I have positive 4b, and I take away a b, then I have 3b. Now guys, here's my question. Have I done the addition yet?
No.
No, I only subtracted b. Do y'all agree with that? So I don't need that subtraction sign anymore. I did the subtraction. I'm going to bring down the plus. The real reason we're doing that is because if I have a positive 4b and I take away a b, I have a positive 3. Okay? Or you can just remember we've already done the subtraction, so put the plus sign. Are we okay with that?
It's 13a plus 3b.
And that's my answer since I don't know what A or B are. Okay? Eventually, you'll end up, in 7th grade, this will end up saying minus 4b and minus b. I want you to think about this, guys. If I take away 4 apples, and then I take away 1 more apple, I'd be taking away 5 apples, right?
Negative 1b.
So it would just change to, I'd be taking away 5 apples. So it would be minus 5b. Again, y'all aren't having to worry about negatives right now. So we're good with this. Are there any questions about this? I know I kind of threw some negative information out at you. Ignore that if it's confusing. All right, let's look at the next one. All right, so I'm going to start with 8x to the second power. Is there anything that matches with 8x to the second power? Raise your hand, please. Brianna.
5x to the second power.
Close. What do you have to keep with that?
Minus 5.
Minus 5x to the second power. So I have 8x to the second power minus 5x to the second power. Why didn't I put 7xy? Why doesn't that match? Macy?
Because the y doesn't have anything.
Thank you, Macy. Okay, because it has a y. What's another reason that that doesn't match? Emma King? It doesn't have that exponent of a 2. Okay, now here's the cool thing about exponents. All right, that just makes the x to the second power special. You don't change the second power. That stays there. It's attached to the x. It's what's making the match. It stays. We don't mess with it, okay? So if I have 8 apples and I take away 5 apples, how many do I have?
3 apples.
3 apples. So I'm going to put 8x minus 5x is 3x, and we're just going to keep that second power with it.
Plus 7.
Okay? Plus 7xy. Is there anything else to go with that?
Nope.
Nope. So we're just going to bring it down. Number 4, I have 11c minus 2 minus 10c. So let's start with 11c. Is there anything that matches it, Macy? What do I have to keep with it? Minus 10c. So I have 11c minus 10c. All right, this one's a little tricky. 11c minus 10c. If I have 11 apples and I take away 10 apples, what am I left with, Brianna? C. I'm left with just an apple. Do y'all agree with that? So 11 C's minus 10 C's is just going to leave me with C. What property tells me 1 C is the same as just C? Not identity of addition, but identity of multiplication. So we would just want to write C. It's kind of like with fractions. Remember, you would ask me all the time, do I have to simplify it all the way? Yeah. Which one is simpler, 1C or just writing a C? C. Just a C. And then we'd have minus 2. Okay. Put a little star next to this. I think there's one like this on your homework. I know there is one like that on your test, where if we're taking it away and there's just one left, I just want you to write the one letter there. Okay? Number 5. Number 5 looks a little bit different, but there's a star separating these. And it says sometimes you will need to distribute. So on these next problems, we are going to need to distribute. So I'm going to kind of look at number 5 with you, and then we'll do number 6 and 7 together. So for number 5, I have a 3 next to my parentheses. Since I can't do x plus 4, we are going to have to distribute that. When I pass that 3 out, so I'm passing it to x, I'm passing it to 4, am I going to pass it to the 10? No. Remember, you only pass it to what is in the parentheses. It's like when I pass out papers. I'm passing it out to my group of students. Am I going to go upstairs and pass them out to Ms. Wright's group? No, you only pass them out to your group. So I'm only going to pass them out to the group in parentheses. So multiplying 3 times x, that gives me 3x. 3 times 4 gives me 12. Just keep that plus sign there. Plus 10x. Now that I've gotten rid of those parentheses, now I can do what I was doing before. All right, so I'm going to start with the 3x. What's going to match my 3x, Brianna?
Plus 10x.
Plus 10x. So if I have 3x plus 10x, what's that going to give me, Jenny? 13x. Have I done anything to the plus 12? So we're just going to bring that down. I really don't know why. These are like my favorite types of problems to do. All right. They are easy. That might be why I like them. All right, but they're kind of like puzzles. And they look like we're doing something really fancy with all those letters moving around. All right. I'm going to take my 2 here, and I'm going to pass it out. So I'm going to pass 2 to 4, which gives me 8. And then minus, I'm going to pass 2 to 2b, which gives me 4b plus 7. All right, again, I'm going to start with the 8. Is there anything I can combine with the 8? What can I combine with the 8? Looking for a new hand. I got some of the same people answering. Am I new? 8 and 7. How did you know 7 would match? Because those aren't the same number. Yeah, 4 has a B. 8 and 7 are numbers by themselves. Does anyone remember what vocabulary word would describe a number by itself? What would describe a number by itself? 7 and 8 are called what? Brianna? Constants. Because an 8 is always an 8. A 7 is always a 7. They're constant. They can't change. And since they're both constant numbers, we can put them together. So I'm going to have 8 plus 7. Keep that plus with it, which is going to give me 15. And then I just bring down my minus 4b. So sometimes when you're simplifying, sometimes they're going to be the same because they have a variable. Sometimes they're going to be the same because they don't have anything next to them. Number 7 is a fun problem. This time, my number that I need to distribute is in the middle of the problem. That's okay, because doesn't multiplication still come before adding or subtracting? Yep. So I'm going to take that 7 and I'm just going to pass it out. So I'm going to leave 4a the way it is, plus 7 times 2b is 14b, plus 7 times a is 7a, minus b. Okay, what am I going to do next? Brianna?
4a and 7a plus 7a match.
So 4a is at the beginning, and it does match with plus 7a. So what's that going to give me?
That's going to get you
11a. And since I'm done with those, I'm just going to kind of mark them out. Okay, is there anything else that's going to match here? Macy? So we have plus 14b minus b. If I have 14b minus b, what is that going to give me? Connor? 13b. So 14 minus a b is 13b. I've used the minus sign, so what do I need to bring down?
Addition.
The addition sign. All right, last one. This one looks weird because now I'm going to actually distribute a letter. Okay, so I'm going to write my 5xy. It stays just like it is. My plus sign, x times 3. How would I write x times 3? Think about all of the other math that we've written down. What's the best way to write that out, Connor? 3x. All right? If you look at all those other problems, the number is in front. We want to keep that. It just looks nice. All right? My little joke about that is if a mathematician had written Star Wars, R2D2 would be 2R2D. Okay, no Star Wars fans in here? Okay, there's my Star Wars joke. Apparently, that's not a thing anymore. All right, so plus, keep our plus sign. Keep our plus sign, and then x times y. What is the best way to write x times y? x times y. What do you think? Aiden?
X, Y.
XY. Guys, mathematicians aren't very clever. They usually do things in alphabetical order because we like things to have rules. Okay. Also, if I write XY, now does it match the 5 in front? Yeah. So, combining, I have 5XY plus an XY. If I have 5 apples plus an apple, what do we have now, Kayla?
6XY.
I got 6 apples, or 6XY. Am I changing the X or the Y? Putting any? No, we're just putting those numbers together, I guess. Okay, then we have plus 3X that hasn't been used. Okay? Questions about that? All right. If you'll flip it over, your homework's on the back.